So here we've got a question that we might need a little bit of thinking about, sort of a pattern. We'll take a look at the question first, and then in the process, you might want to think about what sort of topic might be relevant here and how we might answer the question. And so they've given you a diagram. And so you've got bottles placed in these bins. Each bin has different number of rows. First row up here, second row down here, third row down here, and so on. And as the question says, you've got a bottle storage rack. It consists of n rows. So this goes down to have more rows. And it's in such a way that the number of bins in the rth row is r. So the first row has 1 bin. The second row has 2 bins. The third row has 3 bins, and so on. So your nth row would have n bins, as you'd expect. Right? So that's what we're basically saying, counting from the top. So it's like a kind of pyramid sort of situation. All right. And then we're told we want to show the total number of bins in the storage rack is n plus 1 over 2. And then each bin in the rth row contains some number of bottles. And then you want to find an expression for the total number of bottles in the storage rack. So, okay. Again, it's leading you through a question. You want to show that the total number of bins in the storage rack is n plus 1 over 2. So let's do that first. So you know that there are n rows. And so if we take this look at the row number that you've got, the first row, the second row, the third row, I'll do a kth row in the middle. And then your last row is the nth row, and you know that's your last row. So you're trying to get the total number of bins, ignoring bottles. You're just trying to get the total number of bins. Well, let's look at the number of bins in each row. The first row, as per the definition, has 1. The second row has 2. The third row has 3. The fourth row will have 4. The fifth row will have 5. So the kth row will have k. And lastly, the nth row will have n. So the total number of bins, you can probably see, is you just need to add up the number of bins in each row, which is equal to 1 plus 2 plus 3 plus some number k plus the number n, which basically is just 1 added all the way up to n. And this is just your arithmetic series. You're just adding up a sum. So you might remember that the sum of an arithmetic series is n over 2, where n is the number of terms, times the first term plus the last term. So applying that, we will just say it's n over 2, n plus 1. And that is as required. That's what they wanted you to show. So that's part 1. Now part 2, though, asks you to get an expression for the number of bottles. Now, that needs us to get some idea of what's going to happen with the bottles. So let's take a look. Each bin in the rth row contains C plus R bottles, where C is a constant. For example, each bin in the third row contains C plus 3 bottles. So find an expression for the total number of bottles in the storage rack with this assumption. Okay, so let's now do this with a bit more space. It shouldn't take too much space, but let's just reiterate what we said before. We've just got a nice simple diagram like so. So first row, second row, third row, all the way up to the nth row. So this is your row number. Now we've already just worked out from the question that the number of bins in that row is 1, 2, 3, all the way up to n. And we don't really need this, but we might as well put it in here anyway. It's going to be n over 2, n plus 1, in total n. Okay, so there are total n rows, there are a total of n over 2 n plus 1 bins. But now we want to work out, well, I guess let's look at the number of bottles per bin. According to the question, each bin in the rth row contains C plus R, which means the first row contains C plus 1, because R is 1 there. The second row contains C plus 2. The third row contains C plus 3. And the kth row, which we can type, or the rth row as they put it, the rth row is going to have R bins, and it's going to have C plus R, as they've put in the question. And so, as I said, the third row has C plus 3, and we're fully in agreement with that. And that means then at the bottom there, we're going to have C plus N. So in other words, in each particular bin, I'm going to have, putting it in the diagram, C plus 1 bottles here in each bin. I'm going to have C plus 2 bottles in each bin. I'm going to have C plus 3 in each bin, and so on. But then it's probably quite easy to see that if that is the number of bottles for each bin, well then the total number of bottles on that row is just really going to just be, I suppose, well, I mean, if you think about it logically, the number of bottles per bin, you've got the number of bins, it's really just these two things multiplied together. So really, that's just C plus 1 on the first row, 2 times C plus 2 on the second row, 3 times C plus 3 for the third, R times C plus R for the R, N times C plus N for the nth. Given you're trying to find the total, you just really want to add up those things. So we really do have an expression already, but clearly the question wants us to simplify it a bit more. Okay. So let's do that. So we understand that the number of bottles in the rack essentially is the sum of C plus 1 plus 2 times C plus 2 plus 3 times C plus 3 plus 4 times C plus 4 plus da, 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 plus R times C plus R plus da, 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 plus N times C plus N. Now, because that's a lot of writing, I'm going to use sigma notation. And really, we're just, K goes from 1, I should say. We're really going from 1 to N of K times C plus K, right? So when K equals 1, I've got 1 times C plus 1. When K equals 2, I've got 2 times C plus 2. When K equals 3, I've got K times 3 times C plus 3, and so on until N. So we're really just trying to get that going, remembering that C is a constant. And so what I'm really saying is I'm summing from 1 to N of CK plus K squared. Right? I'm just expanding that. So it's CK plus K squared, which really is the sum from K equals 1 to N of CK plus the sum from K equals 1 to N of K squared. Now this you've been given the answer to. Always pay attention to the information in question. You're told that you can assume the sum of the squares is equal to 1 over 6 k plus 1, 2k plus 1. Remembering C is a constant, it's just C times the sum from k equals 1 to N. It should be N, sorry, that one should be N at this point. Now think of what this means. This is just 1 plus 2 plus 3 plus 4 all the way up to N. Let's just see N over 2 N plus 1. So that really essentially is your expression. They didn't really say exactly what form they want your expression in. So it might be helpful to just try to factorize it a bit. So I'll take out n plus 1, because they both have n and n plus 1. I'll take out 6. So that means I'm going to have 3c for the first term, because I've taken out the n and the n plus 1. I've taken out 1 6, so there's 3. I've taken out n and n plus 1 and the 6th, so then it's going to be plus 2n plus 1. And that's the expression I would get. Just to be clear, in case sigma notation is causing some confusion, what we're really doing is, what I'm saying is I've got c plus 2c. Like if you think about it in terms of c plus 2c plus 3c plus 4c plus nc, right? I'm just going to do all the ones at the start first. I'm just grouping them together. And then I'm going to add 1 plus 2, 2 times 2 plus 3 times 3. So I've got 1 plus 2 times 2 plus 3 times 3 plus 4 times 4 plus r plus n times n plus n squared. So I'm really just splitting into two sort of terms like that. The first one, I'm basically factoring out the c and giving you 1 plus 2 plus 3. I've left out a 3. And this one is 1 squared plus 2 squared plus 3 squared to n squared. And I'm basically just using the fact that this is equal to n plus 1 to n plus 1 over 6. And I'm using the fact that this part is n over 2 n plus 1. And then simplifying to get my answer below over here. And that's how you do the question.